Everyone thinks they know New York, bustling cities, massive waterfalls, and rolling mountains. But what if I told you the ground beneath that famous skyline is changing right now, and new geological formations are being discovered almost every year? From hidden caves to shifting coastlines, New York's geography isn't frozen in the past. It's alive, evolving, and full of surprises. We've pulled together brand new facts that only a handful of researchers could tell you about. Let's kick things off with number 50. You won't see this one listed on any map. Mountains losing ground faster. Fact 50. Mountains don't last forever. The Adirondacks and Catskills look steady, but new 2025 data shows they're being worn down much faster than before. Heavy rainstorms tied to a warming climate are hammering these ranges with unusual force. Instead of slow, steady erosion stretching across thousands of years, scientists are now documenting changes unfolding in just a few decades. Rainfall doesn't just wash away soil, it loosens entire shelves of rock. Researchers measuring runoff have found that in some valleys, soil loss has doubled compared to what was recorded 20 years ago. That means gullies appear where tree cover once stood firm, and rocky faces show fresh fractures with each major storm cycle. When that process accelerates, the shape of the mountain itself starts to shift within a human lifetime. This breakdown creates ripple effects. Hillsides that stay intact for centuries suddenly grow unstable, sending sediment surging into rivers and smothering aquatic habitats. Forests clinging to shallow soils face higher risks of collapse, and wildlife that depends on these slopes has to adapt to new, unstable terrain. So while these mountains may look untouched from a distance, they're constantly shedding, shrinking, and reshaping. In 2025, New York's peaks are being redefined at a pace people can actually witness. Cleaner Hudson, but still struggling. Fact 49. For years, the Hudson River carried a reputation as one of the dirtiest waterways in the country. Industrial waste, sewage, and the long-lasting impact of toxic PCBs made huge stretches unsafe for both wildlife and people. But by 2025, new monitoring reports tell a more complicated story. Large-scale cleanup campaigns, including dredging and decades of pollution controls, have steadily pushed water quality in a better direction. In some sections north of Albany, oxygen levels and fish populations are healthier than they've been in decades. That progress is real, but the river isn't free from threats. Instead of large chemical discharges, today's challenges come from sources that weren't tracked in the past. Microplastics now turn up everywhere in water samples, breaking down from packaging, clothing fibers, and surface litter that finds its way into the river. Storm runoff is another major player. When extreme rainfall hits paved streets, it pushes oil, fertilizer, and untreated waste into the river all at once. These sudden surges undo much of the gradual progress cleanup efforts achieve. The result is a river that is far cleaner compared to 30 or 40 years ago, but at the same time facing hazards researchers didn't measure until recently. In 2025, the Hudson's fight has shifted from industrial toxins to the invisible pollutants of the modern age. Unearthed Adirondack secrets. Fact 48. The Adirondacks are best known for their rugged peaks and untamed forests, but in 2025, researchers working beneath the tree line uncovered something unexpected. Archaeologists found tools and artifacts that had never been recorded before, preserved in soil layers usually overlooked during past surveys. These discoveries suggest that people were living in and moving through this region thousands of years earlier than experts once believed. Stone blades and worked points show that hunting communities made use of the mountains long before European settlement. The surprising part is not just the age, it's what the location tells us. Far from being an isolated wilderness, the Adirondacks now appear to have been part of a much wider prehistoric network of trade and migration. Items crafted from stone, not native to the area, point to connections stretching across regions, indicating steady contact between groups separated by hundreds of miles. What made these artifacts survive is the Adirondacks' harsh soil. Rocky deposits and mineral-rich ground acted almost like a protective layer, keeping delicate items intact where in other northeastern regions they would have decayed. For scientists, that means each discovery adds a rare piece to the human puzzle. In 2025, the Adirondacks are not only peaks of ancient rock, they are rewriting who walked these mountains first. New York's shrinking shorelines. Fact 47. If you walk the shoreline of Long Island or stand in the tidal zones of the lower Hudson today, it doesn't look the same as it did just a decade ago. High tide lines now reach farther inland, and some beaches that were once wide stretches of sand have narrowed to just a few steps. The visible change isn't from storms alone. It reflects steady sea level rise that New York is recording year after year. The newest coastal data collected in 2025 confirms that the state has lost hundreds of acres of shoreline to higher tides alone. Flood zones that used to only activate in hurricanes now expand during normal seasonal cycles. This erosion doesn't only affect homes and properties, it also eats into wetlands that protect towns from storm surges, beaches that serve as nesting grounds, and even the edges of historic landmarks that once stood safely back from the water. Scientists reviewing current maps warn that some neighborhoods are slipping past a point of temporary flooding into something more permanent. In parts of southern Long Island, what was called high water only 10 years ago is now the daily norm. New York's coastline isn't eroding slowly over centuries, it's disappearing at a pace people can track within their own lifetimes. Subway meets bedrock. Fact 46. Expanding New York City's subway system is not just a test of budget and planning, it's a direct fight with the ground itself. In 2025, new tunnel projects are cutting into some of the most challenging geology anywhere in the state. Much of Manhattan rests on ancient Manhattan schist, a rock layer formed more than 450 million years ago. This layer is hard enough to support skyscrapers, but it doesn't behave the same way in every location. Some areas are solid and dependable, while others are fractured with hidden seams and soft zones that shift when drilled. Engineers report that digging rigs encounter sudden surprises. Groundwater seeping through cracks flood sections that were expected to stay dry. Fissures widen without warning, forcing delays and costly reinforcements. Soil pockets, buried long before the first streets were even planned, collapse under pressure, leaving crews scrambling to stabilize the ground. These challenges slow construction, but also expose new insights. Every unexpected rock face cut open by a drill shows off layers geologists have never seen before. Each new tunnel is essentially a slice through time, revealing evidence of mountain-building collisions and long-buried seabeds. New York's subway expansion is therefore not only about moving passengers underground, it is one of the largest live geology lessons happening anywhere in the country. Catskill wildlife on the comeback. Fact 45. Just a few decades ago, the Catskills felt strangely empty of their larger animals. Bobcats were rarely seen, black bear numbers were thin, and the streams lacked the signs of beaver colonies that once shaped the valleys. By 2025, surveys paint a very different picture. A mix of tighter hunting rules, protected corridors, and forest regrowth has allowed populations to steadily increase, filling in gaps that had been missing for generations. Beavers are among the most noticeable. Their dams are now scattered across streams that had run freely for years. These structures don't just hold water, they create entire new wetlands. The ponds slow floods during heavy rains, trap sediment, and provide habitat for fish, amphibians, and birds. Black bears are following the return of acorns and berry thickets, with sightings growing across counties that once reported only rare visits. Predators that need wide, quiet ranges, like bobcats and coyotes, are also gaining strength. Their recovery is a sign that smaller prey populations are being kept in check, which restores balance to the whole food web. Ecologists often call this a keystone effect, where the return of top animals stabilizes the forest itself. In 2025, the Catskills feel more alive than they have in nearly 100 years. Reservoirs under the microscope. Fact 44. New York City runs on something most people never see, the vast system of reservoirs that hold its drinking water. No other city in the country relies so heavily on stored rain and river water captured far from its streets. In 2025, updated testing of these reservoirs shows both strong results and new vulnerabilities that weren't a concern decades ago. The Catskill and Delaware supplies remain among the cleanest urban water sources on Earth. Their natural filtration comes from protected forests that funnel runoff into carefully designed networks of lakes and tunnels. For much of the 20th century, that protection was enough to keep the water clear and reliable. But the picture has changed with stronger storms. Heavy rainfall now washes more nitrogen and phosphorus into the system, nutrients that fuel outbreaks of algae. When algal blooms grow, they block sunlight, choke ecosystems, and reduce clarity in the reservoirs. Scientists are now able to track these changes with a precision never imagined before. Satellite sensors monitor color shifts at the surface, while ground-based instruments test the chemistry hour by hour. The system still provides some of the purest city water on the planet, but climate patterns mean it needs closer watch than ever before. Long Island's shifting base. Fact 43. When most people picture Long Island, they see sandy beaches, suburbs, and highways stretching east. But beneath that surface lies a foundation that tells a very different story. Recent geological surveys in 2025 confirmed that Long Island is not a single slab of land, but the byproduct of one of the Ice Age's largest construction projects. As massive glaciers advanced and retreated, they carried mountains of rock, sand, and clay with them. When the ice finally melted, it dropped that load in a line so huge it shaped the island we know today. In simple terms, Long Island is a giant glacial deposit frozen into the landscape. This structure has left more than just rolling hills and coastal bluffs. Scientists mapping the island's base recently detected vast aquifers buried deep under its sandy soils. These aquifers act like underground reservoirs, holding fresh water that millions of residents depend on every single day, but their position makes them fragile. With rising seas pushing saltwater inland, some of those freshwater pockets are showing early signs of intrusion, a process that could turn drinkable water supplies into brackish, unusable sources over time. Understanding how this glacial formation works is now critical. Long Island isn't just an island, it's a time capsule from the Ice Age that still shifts under modern pressure. Flood zones on the move. Fact 42. The flood maps many New Yorkers grew up with are no longer accurate. FEMA's 2025 redraw has shifted the official flood zones across the state in ways that would have seemed unthinkable a generation ago. Thousands of homes are now listed inside risk areas that had never been considered vulnerable before. This change reflects the new normal: heavier rainfall, flash floods, and steady sea rise that are putting pressure on nearly every watershed in the region. Nowhere is this more visible than the Hudson Valley and Long Island. These two areas have seen the largest expansions, adding entire neighborhoods to the flood zone registry. Families who never once worried about high water are now facing mandatory flood insurance bills. For many, it isn't just a financial strain, but also a signal that extreme weather has already redrawn the environment around them. The map changes go beyond homes. Several school districts and major roadways are now classified inside these revised zones, meaning entire communities depend on routes that could become impassable during storms. Engineers are studying how these updates will reshape future building codes, property values, and even patterns of growth. In 2025, New York's flood danger isn't just a hypothetical, it's officially rewritten on the map. Unwanted guests in every ecosystem. Fact 41. New York's ecosystems are facing a new wave of invaders, and they're arriving faster than before. The spotted lanternfly is one of the most visible examples. It has spread across counties from the Hudson Valley into parts of the Catskills, and vineyards have felt its impact directly. These insects feed on grapevines, leaving behind damaged crops that weaken wine production across a region known for its wineries. Farmers have tried traps and nets, but rising temperatures allow the insects to expand their range more quickly than early models predicted. In the waterways, zebra mussels continue to cause trouble. They attach themselves to any surface, from dock pilings to boat hulls, and spread in dense clusters. Their presence strips nutrients out of lakes, starving native fish populations that depend on those food sources. Once established, they are nearly impossible to remove, and they've already reshaped entire lake ecosystems across upstate New York. It doesn't stop there. Warmer winters and accelerating trade routes allow a steady stream of new species to gain footholds. Some invasive plants change soil chemistry by altering nitrogen cycles, making it harder for native forests to regenerate. These small shifts add up to major consequences. By 2025, scientists say outside species represent as large a threat to New York's environment as climate pressures themselves. The Great Lakes at new levels. Fact 40. For a long time, people thought of the Great Lakes as steady, almost timeless bodies of water. They looked like they stayed the same no matter what happened around them. But new numbers from 2025 show that idea doesn't hold anymore. Lake Ontario and Lake Erie, the two that shape New York's northern edge, have swung between record highs and record lows in just a single decade. These changes used to take centuries. Now they're happening fast enough for residents to notice within a few years. Rising water pushes farther onto the shoreline, eroding bluffs and eating away at fragile beaches. Then, just as communities start adapting, levels drop and expose wide mudflats and unstable docks. Both extremes bring trouble. Harbors rely on consistent depths for shipping, and when water swings too far in either direction, boats can ground out or navigation channels become unsafe. In ports along Lake Ontario, engineers are already raising docks and redesigning walls, only to reconsider those plans when water retreats a few years later. The culprit is a climate system locked into faster cycles. Changing rainfall patterns and shifting ice cover speed up how much water enters or leaves the lakes each year. In 2025, the Great Lakes act less like permanent fixtures and more like unpredictable tide pools reshaping New York's edge. Niagara's new flow. Fact 39. Niagara Falls may look like the same unstoppable wall of water it has always been, but the numbers in 2025 tell a different story. Flow patterns have shifted in ways that would surprise most visitors. Traditionally, the volume of water over the falls has stayed relatively steady throughout the year, regulated by treaties and agreements with Canada and the United States. Recently, though, the combination of climate variation and human management has altered that balance. One of the biggest influences comes from warmer conditions across the Great Lakes watershed. Faster ice melts in the spring are sending more water downriver in shorter bursts, creating seasonal surges much larger than in past decades. At the same time, periods of dry winter weather are producing weaker flows that occasionally lower the curtain of water to levels locals haven't seen in generations. These shifts make the falls appear louder and more forceful in summer, while the off-season sometimes feels noticeably restrained. Hydropower operations also play a role. Engineers divert water away from the main cascades to produce electricity, but must ensure that enough volume remains to satisfy tourism. Striking that balance means the falls are now managed like an adjustable system. In 2025, even this world-famous waterfall depends on climate data to decide how much water people actually see. NYC's scorching heat islands. Fact 38. Cities don't just get warmer, they actually create their own microclimates. Nowhere is that clearer than New York City in 2025. Data shows that downtown neighborhoods can run as much as 9 degrees hotter than nearby rural areas during peak summer. The reason is simple: the city's surfaces. Asphalt, concrete, and glass lock in heat all day and release it slowly at night, while open landscapes shed that energy far more quickly. The result is an urban heat island effect that has grown into a defining part of New York's modern geography. This intensity isn't only about comfort. Higher temperatures strain energy systems as millions of people switch on air conditioners at the same time. Power grids work harder, and blackouts become more likely during heat waves. That added stress also worsens air quality because hotter conditions accelerate ground-level ozone production. And for people with respiratory conditions or without reliable access to cooling, the health risks are immediate. To address it, the city has been testing new approaches. Rooftop gardens, reflective coatings on buildings, and expanded tree canopy projects are all designed to cool pockets of neighborhoods. Some blocks show measurable drops in surface temperature after changes. In the bigger picture, New York's landscape isn't only concrete and steel, it's a system constantly reshaped by the heat it generates. Upstate winds reshaping land. Fact 37. Wind farms may sound like something that only changes the power grid, but in 2025, their effect on the land itself is hard to miss. Across northern New York, large clusters of turbines have risen in specific regions, especially along the Tug Hill Plateau and through the Champlain Valley. These aren't single towers in isolation. They stand in rows that stretch for miles, marking ridges and open ground once shaped only by farms, fields, and forest. Building these installations has required more than placing machines in empty space. To reach steady winds, wide corridors must be cleared, altering tree lines and carving through wooded land that had stood for generations. Gravel access roads run between them, cutting through hillsides and creating clear breaks in the natural landscape. As a result, parts of rural New York now carry straight lines and stark openings that stand out against the irregular shapes of valleys and ridges. The turbines themselves shift the skyline. Where distant views once offered nothing but rolling countryside, giant blades now rotate day and night, visible for miles. Supporters argue they balance out fossil fuel use, but no matter the perspective, they are permanent changes etched into the land. In 2025, renewable energy is quite literally reshaping New York's geography. Finger Lakes, redefined depths. Fact 36. Most people look at a map of the Finger Lakes and assume everything about them has already been measured and recorded. They're long, narrow, and deep glacial lakes. What more could surprise anyone? But in 2025, updated sonar surveys of Seneca and Cayuga revealed something new hiding below the surface. At certain points, both lakes drop into trenches much deeper than earlier readings ever detected. In some cases, this added hundreds of unexpected feet to previously accepted depth records. The discovery came from advances in sonar imaging. Older equipment provided approximations, sketching out depth profiles with limited resolution. Modern systems, however, map the bottom in extreme detail, identifying narrow channels and sudden plunges concealed between ridges of lakebed sediment. These hidden depressions complicate how water flows within the lakes. Instead of smooth circulation, currents plunge into colder zones, creating isolated pockets at the very bottom. Within these zones, researchers are finding ecosystems that had been entirely missed. Colder, oxygen-limited water holds unique species distributions compared to upper layers. That means decades of ecological research only told part of the story. Just as important, the new measurements refine ideas of how glaciers carved the Finger Lakes in the first place. In 2025, these lakes remain deeper, colder, and more mysterious than maps ever suggested. Southern Tier, sliding earth. Fact 35. Not every threat to New York comes with high winds or crashing waves. In the Southern Tier, one of the quietest but most destructive hazards is the land itself beginning to slide. Hills that once looked locked and permanent are now shifting under the stress of saturated ground. With heavier rains falling more often, slopes soak up water until the soil breaks loose, pulling chunks of earth downhill. Highways cutting across valleys are some of the first places to feel it. Pavement begins to crack, guardrails tilt out of line, and whole lanes dip as the ground beneath them creeps inch by inch. It's not only roads under strain, neighborhoods built into these rolling hillsides face the same risks. Foundations settle unevenly, and yards sprout sudden fissures that never existed before. Geologists have been tracking spots across the region, and the results are troubling. Land believed stable for decades is now moving after just a few extreme storms. Modern GPS sensors placed on vulnerable slopes show constant micro-movements, giving officials early warnings before larger collapses can strike. Even with technology, predicting the exact moment a hillside will give way isn't simple. By 2025, the Southern Tier has gained an uneasy new reality. Landscapes once trusted to hold firm are actively on the move. Crowds vs. wilderness. Fact 34. New York's population density isn't limited to cities anymore. In 2025, the impact of people spreads deep into areas once considered remote. Trails that once saw modest traffic now host millions of visitors each year, particularly in the Adirondack Park. Over the past decade, recorded hiking pressure there has nearly doubled. Forest paths that could once recover after a busy season now show exposed roots and wide erosion scars that don't heal between summers. This kind of strain adds up over time. Soil in heavily visited spots becomes compacted under constant foot traffic, pressing the ground into hard surfaces where new plants can't take hold. Instead of a living forest floor, repeated steps grind soil into packed dirt. When rain comes, water runs over the surface instead of soaking in, washing away what little loose soil is left. Recovery slows, plants vanish, and the terrain takes on a new, worn-out look that isn't entirely natural. Researchers now warn that human impact can rival some effects of climate change in these reserves. More visitors mean heavier pressure on fragile land that evolved without this constant attention. Even in the wildest parts of New York, people are reshaping geography just by being present in such large numbers. Fresh wilderness protection wins. Fact 33. Even as cities keep stretching outward, New York has made a major move in the opposite direction. In 2025, the state added new wilderness areas into its Forever Wild protections, expanding the sections of land that must remain free from development. These aren't small parcels hidden away on a map. They include wetlands, forest corridors, and stretches of land that physically link the Adirondacks with wildlife ranges in Vermont. The idea is simple: build natural bridges that animals can use to move between regions without running into highways and neighborhoods. The wetlands, in particular, hold real importance. When heavy rains hit, they absorb overflow and store it like sponges, releasing water slowly afterward. This prevents floods and stabilizes watersheds downstream. At the same time, these restored marshes serve as rare nesting grounds for species that had struggled as old habitats disappeared. Protecting these ecosystems means protecting every layer of geography around them. By locking down more land under this status, New York is layering insurance into its own geography. Natural buffers reduce flooding, forests act as long-term carbon storage, and corridors hold together ecosystems under pressure from climate extremes. The payoff is clear. Wilderness protection ensures that at least some parts of New York's landscape will remain untouched for centuries to come. Fracking's lingering scar. Fact 32. Even though hydraulic fracturing, or fracking, is banned in New York State, the land in the southern tier still carries the signature of early exploration. Decades ago, test wells were drilled into shale formations to gauge potential gas reserves. Those trials didn't result in widespread production, but they left behind subtle geological scars. In 2025, new surveys reveal that the underground record of those activities is still visible. One of the clearest examples is seismic activity. Small earthquake clusters, often too weak to cause damage, have been documented near past drilling sites. These tremors are not random. They trace back to shifts along fault lines disturbed during earlier exploration. The Earth in these areas moves slightly more than expected, and modern sensors continue to track the difference. Water chemistry has also changed. Some aquifers in the southern tier show shifts that researchers connect to testing that happened decades ago. Elevated mineral content and altered flow patterns hint at disruptions between rock layers that were once sealed. Even without current drilling, those marks remain etched into the region. Communities near these sites have grown cautious. Residents know the statewide ban prevents new drilling, but the ground they live on still demands monitoring. In 2025, New York proves that outlawed practices can still leave geological signatures that last for generations. The vanishing empire farmland. Fact 31. Farmland once stretched across huge portions of New York, but by 2025, those open fields are shrinking at a steady and measurable pace. Updated state data shows that every year, thousands of acres of arable land vanish under new roofs, roads, and shopping centers. What was once cropland is now more likely to be carved into subdivisions or commercial strips. The shift is so consistent that entire regions are watching their farming identity fade almost season by season. One of the hardest-hit areas is the Hudson Valley. The same qualities that made it prime farmland, rich soils, gentle terrain, and proximity to New York City, are also what drive development pressure. Housing demand has transformed acres of productive fields into neighborhoods, leaving farmers with fewer places to plant. In counties closest to the city, It's common to see barns and silos standing next to brand new housing tracts, physical reminders of how quickly the transition happens. The consequences ripple far beyond local harvests. As open land disappears, so does the traditional scenery that defined much of upstate geography. The long belts of farmland once stretching between small towns are now broken into scattered fragments, edged by asphalt and concrete. New York's landscape in 2025 looks less like farm country and more like extended suburbia, reshaping the map at a record pace. Hudson Valley's ancient rocks updated. Fact 30. The Hudson Valley may look like nothing more than rolling farmland and quiet towns, but new studies in 2025 show it hides one of the most complex geological stories in the Northeast. Geologists tested new bedrock samples pulled from deep beneath the valley and found layers far older than what had been charted before. These rocks contain fossil traces and mineral signatures dating back to periods when most of the region was thought to be geologically younger. This evidence changes the valley's position on scientific maps and forces researchers to rethink its past. What makes this discovery stand out is how the Hudson Valley formed. Instead of being a simple river basin, scientists now understand it was once a dynamic rift zone. Hundreds of millions of years ago, the crust here stretched and fractured, much like the early stages of an ocean opening. The new rock signatures confirm that tectonic forces tore this region apart, leaving scars buried under fertile soils. That activity places the Hudson Valley alongside global examples of continental breakup, not just regional erosion. Hidden beneath today's farmland is the record of immense tectonic events, some comparable to the opening of the Atlantic itself. In 2025, the Hudson Valley proves it is far older and far stranger than its peaceful scenery suggests. Adirondack acid rain recovery. Fact 29. For much of the late 20th century, acid rain was one of the greatest threats to the Adirondacks. Sulfur and nitrogen compounds carried on the wind fell into the region's lakes and forests, lowering pH and stripping the land of its capacity to support life. Entire lakes, once considered prime fishing grounds, became sterile bowls of clear water, empty of trout and bass. Forests surrounding these lakes bore scars of the same process. Needles yellowed, soils grew too acidic for seedlings, and certain tree species struggled to regenerate. By 2025, new environmental reports reveal signs of recovery that would have seemed impossible 4 decades ago. Regulations curbing smokestack emissions across the Midwest and Northeast cut the pollutants that fueled acid rain. As a result, soil chemistry in the highlands has begun to normalize, and water testing shows pH levels gradually shifting into ranges that once supported healthy fish populations. Trout have now reappeared in lakes that were written off as dead, their return seen as a measure of ecosystem balance coming back. Forests tell a similar story. Stands once thinned by acid damage are growing more vigorously along recovery corridors. Red spruce and sugar maples that had struggled through the harshest years are regaining strength. The Adirondacks now show that even widespread damage can, given time, be reversed. Geology's endangered list. Fact 28. Most people know New York protects its rare plants and animals, but fewer realize the state also keeps track of endangered geological sites. These are formations and landscapes that can't simply grow back if they disappear. In 2025, the state's list highlights places at risk from both natural erosion and human activity, with caves, glacial deposits, and mineral outcrops topping the concerns. Many limestone caves across upstate New York now show signs of collapse as groundwater slowly dissolves their walls. Once open chambers and passageways begin to weaken, parts of them close forever. At the same time, some of the state's iconic glacial formations, like kettle ponds and drumlins, are eroding faster than expected. Farms, roads, and changing rainfall patterns strip away the soil that once preserved their distinctive shapes. Mineral beds, many of them containing rare crystals and unique rock layers, have also been marked at risk. Collectors, curiosity seekers, and in some cases vandals remove pieces that will never return. Tourism adds fuel to these pressures. Trampling feet, unauthorized digging, and general wear all speed up the destruction of fragile locations. Conservationists now argue it's time for a legal framework to protect geological sites the same way biodiversity is protected. Landscapes, like wildlife, can vanish forever if not safeguarded. NYC rivers beneath the streets. Fact 27. Few people walking the streets of Manhattan or Brooklyn realize that rivers still run beneath their feet. Centuries ago, the city was crisscrossed with streams, marshes, and brooks that guided early settlement. Most of them were buried as the grid expanded, covered over by pavement, buildings, and sewers. By the 20th century, their paths had all but disappeared from memory. But in 2025, new mapping projects have confirmed that many of those channels still flow underground, quietly moving water through hidden networks. Survey teams using ground-penetrating radar detected fresh subterranean routes weaving beneath the financial district, parts of Midtown, and sections of Brooklyn that once held tidal creeks. In some zones, water pressure is so strong it forces its way back to the surface during heavy storms, explaining sudden street floods that don't match rainfall totals. Builders working on modern tunnels sometimes break into these lost streams by accident, facing bursts of groundwater strong enough to delay entire projects. Geologists are now redrawing forgotten river maps, piecing together pathways last noted in colonial records. These underground flows keep running whether city life notices them or not. In effect, New York City carries a hidden set of rivers beneath its concrete, veins that continue to shape the land from below. Staten Island's changing edge. Fact 26. Staten Island is where the ocean's advance is easiest to see inside New York City. Surveys completed in 2025 show that its shoreline is shrinking at a pace unmatched by the other boroughs. Marshes that once absorbed high tides are now overwhelmed on a regular basis, leaving less of a buffer each season. What used to be occasional flooding has become almost routine, as tide lines push farther inland and saltwater cuts across low-lying ground. These shifts are not only visible in natural areas. Entire neighborhoods, developed decades ago with the assumption of stable land, are reassessing their future. Some residents now live with water brushing the edges of streets that weren't even mapped in flood zones a generation ago. Local officials continue to study sea-wall designs and other forms of protection, but questions remain about how long these measures can hold back the pressure. Each option comes with staggering costs, and every year of delay means more ground is lost. Out of all 5 boroughs, Staten Island stands as the clearest example of where urban geography meets relentless coastal erosion. For its communities, the disappearing edge is not distant science, it is daily reality. In 2025, this changing shoreline makes the borough a living case study of land loss. Thousand Islands mystery. Fact 25. The Thousand Islands look like nothing more than scattered dots of land breaking the surface of the St. Lawrence River. In 2025, however, new geological mapping revealed that these islands are far from random. Researchers found they are the exposed peaks of an ancient mountain ridge, cut apart and submerged by glacial forces. Rather than small fragments, each island connects to a much larger structure that once stretched across the region like a solid wall of rock. The discovery came from detailed studies of their bedrock. Samples collected on several islands match stone formations found more than 1,000 kilometers north, deep in Canada's Precambrian Shield. Those rocks are over 1 billion years old, meaning the same ancient crust that underpins Canada is also exposed in this river archipelago. The glaciers of the last ice age carved through this ridge, drowning parts of it and leaving the high points above water. What appears today as an island chain is really the eroded top of an ancient mountain system. This reclassification changes how scientists view the St. Lawrence landscape. Instead of small river islets, the Thousand Islands are now recognized as a fractured remnant of one of Earth's oldest mountain belts, quietly resurfacing in New York waters. Beavers as land architects. Fact 24. Beavers are more than just animals living in the backwoods. They are in many ways engineers of the land. In 2025, population reports show their return across the Adirondacks, and Catskills is not just steady but influential. Colonies have grown to sizes large enough that their building activity is altering waterways on a wide scale. The dams they construct look simple, but each one shifts how rivers, streams, and valleys function. When a beaver cuts trees and piles them into a barrier, the result is a pond where clear-running creek once flowed. These ponds spread water out, slow currents, and create wetlands that did not exist just 2 decades ago. In storm seasons, they serve as natural breaks, holding back sudden runoff that would otherwise race downstream. The effect is visible across multiple watersheds, less flash flooding and slower erosion of stream banks. The new wetlands enrich biodiversity too. Amphibians, fish, and birds all move into the stable ponds built behind the dams. Trees along the edges also benefit from consistent moisture once absent. Researchers now consider the beaver one of the most effective natural shapers of land in New York. In 2025, a single species demonstrates how animal behavior can transform geography. Tapping into Earth's heat. Fact 23. When most people think about geothermal energy in the United States, they picture the hot landscapes of Nevada or California. But new tests in 2025 have revealed something surprising beneath New York's surface. Deep under the Adirondacks and Catskills are layers of rock, storing much more heat than anyone expected. These rocks have held energy for millions of years, pushed upward as old mountains formed, and they may one day be tapped to power entire towns. The measurements show temperature gradients high enough to compete with well-known geothermal regions out west. At certain depths, the rock is naturally hot enough to generate steam strong enough to run turbines. This potential changes the way scientists look at New York's underground. Instead of seeing only old granite or metamorphic layers, they now recognize a reserve of energy locked away inside them. The biggest barrier is distance. To reach these hot rock layers, wells would need to be drilled miles below the surface, far deeper than most conventional drilling projects ever go. At present, the cost and equipment make it difficult, but advancements in drilling technology are already reducing those challenges. Beneath New York's bedrock lies a power source older than its mountains, waiting for the right tools to access it. Volcanic traces still visible. Fact 22. The Hudson Highlands don't look like volcano country. The hills are green, the trails are popular, and the bedrock shows nothing dramatic at first glance. But new geological updates from 2025 reveal that beneath the surface, the story is very different. Rock samples once labeled as ordinary tectonic remnants now show clear volcanic minerals embedded within them. These aren't random traces, they point to an eruptive past that shaped the region hundreds of millions of years ago. For a long time, the prevailing idea was that the highlands were simply part of old mountain-building events, pushed up and fractured by ancient collisions. What recent studies suggest instead is that magma once forced its way into these formations, cooling into igneous rock that still sits locked in place. Tiny crystals of volcanic origin are the evidence, preserved over geologic timescales despite pressure and erosion. Their distribution across the range implies not just single intrusions, but multiple eruptions. That means popular hiking paths winding through the forests are crossing what survives of an extinct volcanic field. The peaks may not glow or rumble today, but the land records fire and ash from far in the past. New York hides volcanic scars under the canopy of the Hudson Valley. Long Island Sound growing deeper. Fact 21. Long Island Sound may appear steady from the surface, but new 2025 mapping shows the seabed below is shifting in surprising ways. Using high-resolution sonar, researchers found that some valleys along the bottom are growing deeper than ever documented. What once looked like a relatively flat underwater plain is now understood to be a landscape with ridges, troughs, and channels being carved even today. The cause isn't mysterious. It comes down to stronger tidal currents and erosion. As storms deliver heavier pulses of water, powerful flows scour away sediments that collected over thousands of years. Instead of filling gaps, the currents pull material out of them, deepening valleys and creating sharper relief. Over time, these channels act like unmarked rivers under the surface, constantly adjusting the depth profile of the sound. This reshaping doesn't stay hidden. Changes in depth alter how fish use the water. Shallow zones once filled with shellfish now transition to deeper habitats, and species move with them. For communities along both New York and Connecticut shores, the fishing grounds they depend on are already shifting. Local industries have started adapting gear and adjusting routes, but the message is the same. The sound isn't static, it's redrawing itself beneath the waves. Ice Age ghosts emerging. Fact 20. The last ice age never really left New York, it just went underground. In 2025, fresh discoveries are proving how much of that frozen past is still hidden, waiting for erosion or construction to bring it back into sight. Retreating soils and ongoing development cuts are exposing massive glacial erratics and preserved fossils that had rested for thousands of years beneath layers of sediment. Glacial erratics are giant boulders dropped by retreating glaciers tens of thousands of years ago. Some of the latest finds rest in farmland fields where plows only recently scraped away the surface. These boulders don't match the local bedrock, confirming they were carried here from distant regions on sheets of ice and dropped like forgotten cargo when the glaciers melted. Their sudden appearance tells researchers exactly how far these glaciers once stretched. Plant matter is surfacing too. Layers of soil pulled back by erosion reveal remains of ancient vegetation sealed in oxygen-poor conditions since the Ice Age. Frozen or compressed seeds, logs, and roots have been uncovered intact, giving scientists living records of what once grew here. Dozens of these sites are now documented across the state, each one a snapshot of a vanished ecosystem. Piece by piece, New York is unlocking time capsules left behind by glaciers, reminding us that Ice Age history is still unfolding in plain sight. Cave systems expanding. Fact 19. New York may be famous for mountains and rivers, but beneath the surface lies an often overlooked feature: its expanding cave systems. Updated surveys in 2025 have revealed that these networks are larger than what researchers ever recorded in the 20th century. Using modern imaging tools, scientists now see channels stretching much deeper and farther than the early maps suggested. These aren't just cracks in rock, but extensive corridors winding for miles in darkness. Most of these findings come from limestone regions, where water has been carving pathways for millions of years. The process is slow but persistent. Rainwater seeps through, weakens the stone, and gradually expands into caverns. What earlier explorers thought were dead ends are now shown to connect into larger underground waterways. Some passages weave beneath farmland, while others stretch under protected forests and state preserves. In total, entire miles of cave remain waiting to be charted. The scale is surprising. Specialists working with current data estimate that only half the actual mileage of New York's cave systems is documented. That means what is currently on paper might represent just a fraction of the whole. In 2025, beneath homes, fields, and parks lies a shadow geography still unmapped, larger than anyone realized. Champlain Valley's hidden formation. Fact 18. The Champlain Valley seems straightforward at first glance, wide farmland bordered by mountains and filled with a massive lake. But studies completed in 2025 prove it has one of the most unusual origins in North America. Most valleys in this region can be traced to glacial scouring, when ice sheets carved out troughs and left behind broad plains. That did happen here, but new rock evidence shows the Champlain Valley is not just glacial. It is also the scar of an older tectonic split, where sections of the Earth's crust pulled apart long before the last ice age. Researchers studying bedrock cores revealed formations typical of rift zones, areas where plates stretch and fracture. Over time, glaciers arrived and deepened those fractures, chiseling them into the shape we recognize today. The overlap of these two forces, tectonic rifting and glacial excavation, makes the valley an unusual hybrid. It carries fingerprints of events separated by hundreds of millions of years, layered together in the same landscape. This collision of histories helps explain why fossils of vastly different ages appear within a few miles of each other. Marine shells from an ancient sea rest not far from glacial debris, only tens of thousands of years old. The Champlain Valley is a working case study of multiple earth-shaping forces colliding in one place. Its beauty is really the product of contradictory origins layered into a single stretch of land. Microclimates within miles. Fact 17. You don't have to travel far in New York to feel like you've stepped into an entirely different climate. In fact, new data collected in 2025 shows just how dramatic these microclimate shifts really are. In the western part of the state, vineyards are reporting longer growing seasons, with harvests stretching further into autumn than previous generations ever experienced. Warmer nights and extended frost-free days are giving grape growers chances to expand varietals that once struggled in cooler weather. Yet just a few hours north, the opposite trend emerges. The higher ridgelines of the Adirondacks and the Tug Hill Plateau are holding snow well into spring, in some cases weeks later than the valleys below. These colder pockets gain from elevation and local wind patterns that concentrate chill in ways coastal areas never experience. The effect creates sharp boundaries, rolling farmland in the lowlands and snow-locked trails just a short drive away. Cities create their own signatures, too. Dense pavement and glass absorb and trap heat, making metro zones run several degrees hotter than the countryside outside them. Storms also interact differently in these zones, dropping heavier bursts of rain where heat drives convection. In 2025, New York's landscape proves that climate doesn't follow neat regional lines, it shifts mile by mile. Glacial shapes disappearing. Fact 16. The marks left by the last ice age are fading, and by 2025 the change is unmistakable. Across New York, the carved shapes glaciers once pressed into the land are disappearing piece by piece. Hills smoothed by ancient ice sheets, shallow kettle ponds, and delicate ridges once clearly outlined on maps are being erased before our eyes. These features were created over thousands of years, but they are now vanishing within a few generations. One of the main forces at work is soil loss. Farming districts cut into former glacial landforms, removing protective cover and loosening the earth that gave these shapes their definition. In other regions, heavier rainfall tied to shifting climate is scouring away surface layers, stripping down terrain in ways older maps no longer match. Flooding accelerates the process, washing away entire depressions that once held water. Drumlins, the elongated hills sculpted under moving glaciers, are among the most at risk. Researchers report that certain clusters are collapsing faster than natural erosion rates would predict, flattening into unremarkable mounds with each passing decade. Geographers now race against time, recording every ridge, hollow, and pond before new development or weather erases them. Without intervention, some of New York's most iconic glacial fingerprints could be gone completely within the next 100 years. The state's wealth below. Fact 15. New York's natural wealth isn't only on the surface. Beneath its forests and farmland lies one of the most resource-rich underground profiles in the Northeast, shaping both history and modern industry. For centuries, people have tapped deposits of iron, talc, and garnet hidden in the Adirondacks. Today, updated surveys in 2025 show that the state still carries minerals with global importance. Only now, some of them are critical for electronics and renewable technologies. In the Hudson Valley and parts of the Adirondacks, small but valuable pockets of rare minerals are currently being extracted in limited amounts. These include metals essential for microchips, batteries, and communication devices. While the deposits here aren't massive compared to overseas reserves, having them within state borders gives researchers and industries a new level of interest. It proves these old mountain belts still hold resources tied directly to modern supply chains. Syracuse's underground salt deposits remain a powerhouse. The mines that carved out New York's reputation as a salt city still operate, moving millions of tons each year. But alongside salt, experimental projects are now testing for lithium reserves, an element at the heart of battery technology. If those efforts succeed, New York's subsurface will carry as much value for future energy systems as it once did for preservation and trade. Ancient landscapes made by people. Fact 14. Most people assume New York's valleys and riverbanks were shaped only by nature, but new discoveries in 2025 prove human influence goes back thousands of years. Archaeologists and geographers working with advanced imaging technology uncovered evidence of pre-Columbian landscape modifications hidden beneath forests and farmland. What looked like untouched land has revealed terraces, mounds, and even remnants of canal-like channels guiding water through floodplains. These features show that native communities didn't just live with the land, they actively engineered it. Remote sensing has been key to these findings. LiDAR scans, which cut through tree cover, outline patterns impossible to see at ground level. Fields, drainage systems, and leveled terraces emerged on digital terrain maps, many of them invisible for centuries beneath natural growth. These alignments aren't random, they follow clear designs linked to agriculture and settlement. Crops planted on terraces would have been protected from erosion, while water channels directed seasonal flooding into controlled areas to improve soil fertility. Each discovery challenges the idea that early people were only adapting to New York's environments passively. Instead, the evidence suggests organized systems of land management shaping ecosystems in deliberate ways. Geography in these regions is not just the product of glaciers, rivers, and climate. It carries the signatures of civilizations long forgotten. Humans shaped New York's landscapes thousands of years before New York even existed. Rivers running underground. Fact 13. Beneath much of upstate New York, rivers are flowing in places no one can see. Farmland, forests, and even small towns sit on top of underground highways of water, carved through limestone and bedrock over millions of years. In 2025, new models show these hidden systems are far more extensive than early surveys ever suggested. Much of this activity is tied to karst terrain, where water dissolves carbonate rock and creates pathways that can carry entire rivers out of sight for miles. These underground flows don't just vanish permanently. In many locations, the water resurfaces at powerful springs that seem to appear from nowhere. To early settlers, these sudden fountains looked almost magical, clean, cold streams bursting straight from the base of cliffs or hillsides. Modern mapping reveals they are part of the same networks of rivers that slipped beneath the surface miles away. The impact reaches beyond scientific curiosity. These hidden channels help explain why certain regions see constant flooding while nearby areas remain unexpectedly dry. When heavy rain enters an underground river system, it can reappear in a surge on the other side of a valley, overwhelming one town while leaving another almost untouched. In 2025, invisible rivers continue shaping New York's landscape as strongly as the ones shown on maps. Forests versus hurricanes. Fact 12. Every major hurricane that sweeps through New York leaves a trail in the forests that can still be tracked years later. Satellite images taken in 2025 show that storms from the past decade reshaped entire stands in the Adirondacks and Catskills. Large swathes of trees that once formed unbroken canopies now show patchwork gaps where winds ripped through. Those gaps let in sunlight at levels the forest floor hadn't seen in centuries, creating microhabitats that trigger new cycles of growth. The recovery rates tell a story of resilience mixed with transformation. After storms in the 2010s, certain hardwood stands bounced back with dense young saplings, while nearby ridges shifted almost entirely to new species that thrived under the altered conditions. Some valleys now host miniature ecosystems distinctly different from the forests that preceded them, shaped by drainage patterns changed when root systems were torn out. What looks like natural regrowth from the road is actually the result of massive reordering introduced by storms. Researchers tracking aerial patterns note that these scars do not fade quickly. Even 20 years after the strongest hurricanes, their outlines remain etched across counties. In New York's forests, hurricanes act with the force of loggers, rearranging the landscape long after the winds go silent. Wetlands returning. Fact 11. Wetlands used to cover enormous parts of New York, but for centuries they were drained, paved, or plowed under for farms and development. By the mid-20th century, large stretches of marshland had nearly disappeared. Now, in 2025, the numbers show a shift in the opposite direction. Updated state records confirm that thousands of acres have been restored or are actively in recovery, turning back the trend of decline. These restored wetlands act as natural storm shields. When heavy rain hits or hurricanes track inland, low marshes absorb the surge, storing floodwater instead of letting it race downstream into neighborhoods and roads. The effect is measurable: flood risks fall in areas with active wetland recovery, but the benefits don't stop with flood control. These same marshes now pull carbon out of the atmosphere, locking it into rich wetland soils more effectively than many forests. Wildlife has responded quickly. Bird survey data shows that herons, waterfowl, and rare marsh species are returning where drainage once destroyed habitat. Even amphibians, among the most sensitive indicators of environmental health, now thrive in ponds created by wetland expansion. Former farm fields are part of this story, too. Agricultural land reworked into marshes has reshaped floodplains entirely. What people drained for centuries is now being restored as a form of life-saving geography. Mohawk River's quiet switch. Fact 10. The Mohawk Valley has always been central to New York's geography, once serving as the most important east-west corridor for trade and travel across the state. But today, the river that carved it is not holding the same course it once did. Surveys taken in 2025 show the Mohawk River actively reworking its path, cutting into new loops and abandoning stretches that had been stable for generations. These changes sound minor on paper, but on the ground, they are redrawing how water moves through an already flood-prone region. Near Schenectady, the river has begun scraping into fresh curves, leaving behind sandbars and oxbows where steady channels once flowed. In Utica, engineers tracking shifts report that portions of the old riverbed are drying out, while entirely new channels take shape nearby. These adjustments may be natural, but they alter everything from how maps outline flood plains to where future construction can safely occur. A neighborhood that was outside any risk zone 10 years ago may now sit in the direct path of redirected water. Transportation corridors across the valley are also affected. Highways, bridges, and rail lines that depend on predictable flow patterns must adapt to a river that refuses to stay still. The Mohawk proves geography is never fixed. It constantly rewrites itself. Manhattan as it once was. Fact 9. Picture Manhattan before streets and towers, when the island's shape was defined only by ridges, streams, and wetlands. In 2025, new 3D mapping technology reconstructed that original topography in detail for the first time. What it shows is an island very different from the flat grid people walk today. Large portions of Harlem rose as steep ridges, while downtown was cut with marshes that spread through areas now packed with buildings. Midtown had streams crossing the ground where avenues run today, carving paths that dictated how neighborhoods eventually formed. Those early features mattered more than anyone realized. Streets didn't just appear randomly. They followed ridgelines that were easiest to build on or avoided swampy zones too expensive to drain. Some major intersections sit where streams once crossed open meadows. Even Broadway owes its crooked path to these old contours, wandering along a natural high ground instead of cutting straight lines like the rest of the plan. Seeing the reconstructed landscape gives new perspective to how the city developed. Manhattan wasn't an open slate waiting for engineers. Its geology had already written part of the plan centuries earlier. The modern island is, in many ways, a city sculpted by forgotten geography. Blocked drains, wider floods. Fact 8. When you cover the land with roads, parking lots, and subdivisions, you cover more than just open ground. You bury the natural drainage network that once carried rainwater away. Across New York, expansions in the last few decades have placed asphalt and concrete squares over wetlands, creeks, and small channels that served as the state's hidden plumbing. By 2025, the consequences have become visible in daily life. Even mild storms can now overwhelm streets, turning low spots into ponds that linger for hours. What's happening underground explains the problem. Creeks that used to meander across meadows now vanish into culverts running beneath highways and neighborhoods. Those pipes weren't built to handle the intense downpours tied to today's climate. Instead of filtering water slowly through soil, the culverts send huge volumes rushing into storm drains that quickly back up. Yard flooding and street closures follow, even when the total rainfall wouldn't have caused trouble in the past. In corners of the Hudson Valley and in newly developed suburbs on Long Island, the story repeats. Identical houses sit on what was once natural floodplain, and paved over ground leaves nowhere for water to soak in. The redesign of land has redesigned the risks. By sealing off streams and covering wetlands, urban growth has turned entire neighborhoods into flood traps. Soil chemistry shift. Fact 7. Soil may not look like it changes much, but updated testing in 2025 shows New York's dirt isn't the same as it was a few decades ago. Across the state, shifts in agriculture, rainfall, and climate are altering the basic chemistry beneath our feet. Farmers and researchers are now tracking large changes in nitrogen, carbon, and acidity, elements that decide how well land can sustain crops, forests, and entire food chains. Nitrogen, once balanced in many farming regions, has built up in heavier concentrations due to fertilizers and runoff. Too much of it can cause leaching into groundwater and overstimulate certain plants while destabilizing others. At the same time, soil carbon patterns are adjusting. Some areas store less organic carbon than they once did, thinning out the natural fertility that crops depend on. In contrast, fields that rotate cover crops often show increased carbon, creating unequal patterns that vary mile by mile. The acidity shift is among the most challenging. Some soils are trending more acidic after decades of rainfall, carrying subtle chemical changes, while others lose acidity entirely. Farmers report that traditional plantings no longer behave the same. Grapevines require adjustments, staple crops demand different treatments, and forests shift their growth balance. This invisible geography proves that even the dirt itself is evolving within New York's borders. Shaking underfoot. Fact 6. Most people don't connect New York with earthquakes. When you think of seismic activity, you usually picture California, Alaska, or maybe the Pacific Ring. But new studies in 2025 show New York is far more restless than most realize. Across the state, minor tremors register on seismographs every year, and some are strong enough to be felt in small towns. They don't grab headlines, but their frequency is higher than what most residents imagine. One of the main areas to watch sits in the north, the St. Lawrence seismic zone. This zone still produces occasional quakes above magnitude 3. For perspective, that's large enough to rattle dishes, crack plaster, and remind people that the ground isn't fixed. Upstate communities along this corridor know these small jolts aren't rare, they are part of the landscape. But it's not only the north. Sensors also show consistent microquakes beneath the Adirondacks and Hudson Valley. They are minor, yet they prove the crust here is always shifting. Even deep beneath Manhattan, fault lines exist. While the chance of a major event is low, the risk carries serious weight in a borough packed with dense skyscrapers and infrastructure. Beneath its surface calm, New York remains restless earth. New York State is not a fixed landscape. Its rivers shift, coastlines retreat, and mountains continue to erode, proving that geography is always in motion. In 2025, changes unfold faster than past generations ever expected, with climate, people, and natural forces reshaping the land at once. Flood maps look different from a single decade ago, while ancient rock discoveries rewrite history beneath modern farmland. Every valley and ridge holds traces of both human and natural influence. Looking across New York today, it's clear that each mountain, shoreline, and waterway is still creating the next chapter of its story.